We're studying IGCSE chemistry, and we're starting chapter 16, extraction of metals 1. First class on the series, and let's just recap what we did. Lula, tell me, what did we learn in the last class? Recap.
We learned about general equation groups and what is a redox and we learned about displacement reactions as a redox reaction and what's redox and in general what are displacement reactions, reducing agents and oxidizing agents.
Okay, with electrolysis. Now, Safa or Zahara, tell me, what did we do in the last class? Which in your last class, which I took a recap, I think.
Class? School class or online class?
With me on
you?
Saturday.
With you, we studied physical properties of metal. We studied about alloys, and we were having some different kind of metals to exchange them with each other. Can we use it or not? And then we studied different kind of metals. Yeah.
Alloys.
Yeah.
We did alloys. Now, okay. So we have extraction of iron, extraction of aluminium, and finally, the last thing we're looking at today is going to be extraction of ways of galvanizing for rust prevention. Let's start. Okay, so first thing first, we look at the extraction of metals based on reactivity series. That's the first thing we're doing. Let's see. I like the reactivity series here. I have a, let's say I've memorized this like this. Kan, kama, zaf, sab, ka. Let's write the words here. So K, Na, calcium, magnesium, aluminium, zinc, iron, Sn, which is tin, then lead, then we have copper, then we have Ag, then we have Au, then Pg. This is the reactivity series. Now, you have to write this in your notebook. Start writing. And write this as the reactivity series. Reactivity series. Now, whatever I'm writing, it should be in your notebook. Is that clear?
Sir, do I also need to write this since I have already written it?
You have to write it again.
Okay.
Everyone. Now, why do I have to write it again? Because it will help you memorize it, or it will make a habit. Now I will divide it from here, from zinc, and we'll divide it from here at copper. Now these are main divisions which we make. So from zinc and from copper, these four are like always separate, and these guys, these five are always separate. Next thing we're looking at is the method of extraction. Method of extraction. Write it in your notebook. The method of extraction is the reduction in electrolysis. Next thing is reduction with carbon by heating. Or by heating with carbon. And lastly, we have no extraction needed or occur naturally. Now, Safa, read this out loud from the beginning. Let's say we'll call it section 1, part, let's say, reactive. These are reactive metals. These are less reactive. And finally, we have not reactive, or let's say unreactive. Now, Safar, start from here. For reactive metals, what is the method of extraction? Safa,
Yes, sir.
start reading.
So should I read the one you write in the black?
Yeah, in the yellow part only. Let's say this one, this and this. Start with metal, reactive, method of extraction, this.
Reactive, method of extraction, and a reduction in electrolysis. Less.
Lola, read the next one.
Less reactive, reduction by heating with carbon or carbon monoxide.
Diana, the last one.
No reactions occur naturally.
Okay, naturally. So you don't need to extract them. You'll find when you go to, let's say, a mountain, you'll find copper and platinum as natural. You don't have to, let's say, take an ore. They don't have an ore. So no ore, no ore. So what you have to write in your notebook is this. This part, just a second. This, and this.
So only this both or the whole?
Not the box only, whatever is highlighted with yellow. So actually you have to write the whole thing. The whole thing, the reactive, the table, plus occur naturally over here. You don't need to write this part. Tell me when all of you are done writing.
Done, sir.
Done,
Me
who's
too.
remaining?
So I'm writing.
Okay, Zahra, finished?
Yes, sir.
Okay. So if I take your time. Now after this, we'll start with, the first thing is extraction of iron. In your book, it's extraction of iron. Now start writing as well. It has something, it has an ore. The name of the ore is, well, ore is like a rock. Okay, I'll show it to you. Ore of iron. Just a second. Now, can you see this on the screen? The photo, this one. Now,
Yes.
do you know the name of this? What is it? It's called hematite. What is it? I'll write it first for you. Hematite. And the chemical formula is Fe2O3. Write this in your notebook. Tell me when you're done. Now, this is what it looks like. I'm just showing it to you, so it's kind of interesting because these are real world things which we're dealing with.
Answer.
And this iron is called iron oxide. What is it called? Iron 3 oxide. Now, why is it called iron 3 oxide? Because the charge of iron here, if I make it like this, is 3 plus, and the charge of O is 2 minus. So what is the charge of iron, Diana? Over here.
3 plus.
3 plus. And I'll take this to the over here, and I'll take this over here. Whenever I'm reacting iron 3 plus with O2 minus, I'll get this product. So 3 goes with oxygen and 2 comes here. So it becomes Fe2O3. Is that clear? Crisscross. This goes there and this guy comes here. Any questions?
No, sir.
Now this charge 3 plus is why we call it iron 3. If it had 2 plus, then it would be called iron 2, and this would be Fe2O2. Or simplified would be FeO. But we don't have that. That doesn't occur naturally. So we only have Fe3 plus. It's called iron 3 oxide. I hope that's clear. Just revision of the old chapters. This is chapter number 3. Now, okay. Next thing is, Safa, how much have you written?
Sir, I'm done.
Done. Let's continue then. Now the next thing we're doing is looking at how do we extract this. So ore is hematite, Fe2O3. And after that we have, let's look at the book. Just a second. Now can you see the book on the screen? Can you see the book?
Yes, sir.
Yes. Now we have this right here. Look, extraction of iron from its ore. Start reading from here. Diana, quick.
Extraction of iron from its ore. Iron is the second most common metal in the Earth's crust. The main ore of iron is hematite, Fe2O3. This ore is rich in iron, containing more than 60% iron.
Now they won't ask if it's 60%, so you don't have to memorize that. Next thing is Safa, start reading.
Production of iron in the blast furnace. The iron is obtained by reduction with the carbon in a mixed furnace.
In a blast furnace. What is it?
Blast
Furnace. And continue reading. The furnace is a mic's on all of you. Steel tower.
Is a steel tower about 30 meters high. It is lined with refractory heat resistant bricks of magnesium oxide that are cooled by water.
Okay, now Zahra, continue.
Furnace is loaded with the charge of raw materials which consist of iron or form of carbon made from limestone, a mineral form of calcium carbonate. The charge is sintered, the ore is powdered and heated with coke and limestone to make sure the solids mix well, and it is mixed with more coke. Blast of hot air are sent into the furnace through holes near the bottom of the furnace. A series of chemical reactions takes place within the furnace to produce molten iron.
Okay. Now, Lula, read the highlighted part one more time.
In the beginning,
From the actually don't read it. Now let's see what is important here. I'll give you these steps. Fine. There are a few steps happening here. Let's look at the book. Actually, yeah, Lula, read it one more time. Yeah, the highlighted part.
it is lined with refractory heat-resistant bricks of magnesium oxide that are cooled by water. The furnace is loaded with the charge of a raw materials which consist of iron ore, coke, a form of carbon made from coal, and limestones, a mineral form of calcium carbonate. The ore is powdered and heated with coke and limestone to make sure the solid mix well, and it is mixed with more coke. Blasts of hot air are sent into the furnace through holes near the bottom of the furnace. A series of chemical reactions take place within the furnace to produce molten iron.
Fine, perfect. Now this is the whole reaction happening. We look at it on the whiteboard now. Look, let's imagine this. The blast furnace will look something like this. It's a big tower. Let's imagine a very big tower of something like this. You must have seen this perhaps somewhere. And then at the end, we have some things here. Let's remove. Fine. What happens is, in the beginning, you put, okay. Let's say you have, okay, this is your blast furnace. And I want you to imagine a few more things here. This is called the blast furnace. It's like an oven. What is it like? What is it like?
Oven.
oven. Now we have this thing at the sides of these. You must have seen in the oven we have some bricks. Now in this we have magnesium oxide bricks. Which bricks?
Magnesium oxide.
Magnesium oxide. This orange part here. Let's make it like this. Okay. Now these bricks are used for some reason. I'll tell you afterwards. First, let's see what main thing is happening. Now these bricks are called magnesium oxide. Just a second. Oxide bricks. Okay. Because it has to keep all the heat inside, and then we also cool it. How do we cool it? We have some let's say water going through outside. So we'll also have some water outside to heat it, to cool it. But the main thing here is you're putting a few things. You have the ore, the iron ore. Okay. And with the iron ore, you have one more thing. You have coke. Let's write it down. The raw materials. Write this in your notebook. The raw materials are coke, iron ore, and limestone. And we're also putting hot air. Write this, tell me when you're done.
Sir,
Yes.
actually, I'm not having the same book. Like, I'm having the different edition. My
Different
edition is.
No worries. We'll look at that book as well. I have it. Fine. But right now the key main thing is to focus on the process of extraction. And everything is on the whiteboard. Send me the picture of your book. Now, guys, have you written this?
Yes, sir.
Okay, coke. After coke, also write something else, which is carbon. In brackets. Now I'll tell you the steps. The first step is that we put coke in the blast furnace. Step 1. Put coke in blast furnace, which burns in air and releases heat, which makes furnace hot. Now read this line. Lula, read it out loud. First step.
Step 1, put coke in a blast furnace, which burns in air and releases heat, which makes furnace hot.
Okay, that's the first step. The equation, write everything down from the first step as well. You don't have to write the diagram. So carbon plus oxygen in the air gives us carbon dioxide. Now this reaction is exothermic. How do we know that? I'll write a delta H is negative, which means whenever delta H is negative, it will mean that the reaction is exothermic. So that's done. Second step is more coke / carbon is put in, that then reacts with carbon dioxide. Or let's just say carbon dioxide rises in furnace and reacts with more coke / carbon put in. The equation for this is carbon dioxide gives us plus carbon gives us carbon dioxide, carbon monoxide. Write the equation as well. And
Sir, should we copy from point number 1?
point number 1, yes. Now, Diana, read the second point.
Carbon dioxide rises in a furnace and reacts with more coke carbon put in.
Coke is another word for carbon, right? It's just from coal. Coke means coal as well, which is completely made up of carbon. So the word coke and carbon mean the same thing. Now, so first what they do is put coke, and that will burn with the carbon, will burn with air and will make carbon dioxide, which is a gas. I'll write the chemical equation here as well. C plus O2 gas. Write this as well. In this first step will give us CO2 gas. Now you need to write this as well. In the exam, they'll ask you. Second thing is CO2 gas reacts with carbon again, carbon solid, to give us CO2CO gas. Now, Safa, read this equation.
Carbon dioxide plus carbon gives carbon monoxide.
Read the chemical equation.
O2 gas plus C will give us
2CO, which is gas. So CO means carbon monoxide. Mono means 1. So we have 1 oxygen here. Mono means 1. So we say monooxide. Di means 2. So that's why we have CO2. So dioxide. Now the final step here is I'll do questions, but keep writing, finish writing quickly. The last thing is iron ore is reduced by carbon monoxide. 3-step process. Well, not a 3-step, there's one more step, but pretty simple. You put carbon, coke inside it, the carbon, and it reacts with oxygen, gives us carbon dioxide. Then carbon dioxide reacts with carbon, gives us carbon monoxide. Now this carbon monoxide reacts with iron ore, which is this equation right here. Iron 3 oxide plus carbon monoxide gives us iron plus carbon dioxide. Now, Zara, read the third step and the equation.
Iron ore is reduced by carbon dioxide. Iron trioxide plus carbon monoxide gives us iron plus carbon dioxide.
Now we don't say try, we call this 3.
Sure, our chemistry teacher calls this try. Or is it another thing?
No, it's not another, you can't call it try. Try
And
is when we
she
have,
also gave us like numbers, you know. Fourth, I guess for the 6th or 4th, yeah, she gave us numbers for this.
say that again, number of what?
Yeah, she like, for example, I'm saying here 3 trioxide. She gave it for others also, like for number 1. No, especially for 2, 3, and 4. This is all what I know. Last class, I
Okay,
guess.
never mind. Write this and ask me if you have any doubts in this. Right? Feel free to ask me anything. You can ask me what carbon means. You can ask me what bi means. You can ask me what is means. That's no problem. But understand and memorize whatever I'm writing on the board. We'll solve questions quickly. First, we have iron oxide. Okay, this is called Fe2O3. So it's obviously not tri. If it was tri, it would be Fe3O2, which is wrong. It's Fe2O3. We call it iron 3 oxide, not tri. Then we have CO. Then we have Fe. Then we have CO2. Gas. This is solid. This is, well, it's not solid, it's molten, which is liquid. Carbon monoxide is gas. This is solid. Any questions? Ask me questions and finish writing. Diana, any questions here?
No.
Lula,
No, I'm done, sir.
finish writing?
Yes.
Okay. Now, after this, iron is reduced by carbon monoxide. We'll put one more line here. What we'll put here is iron is reduced by carbon monoxide. Then iron is taped, let's say molten iron is tapped off from bottom. Bottom of furnace. Now you may realize that we have something here. Look, you see this? You see this tap kind of thing over here? Look, this part and this part. What happens is iron comes like this. Let's say iron reacts with carbon monoxide over here. It's very hot, and then it goes out like this. Any questions? That means taped off or tapped off. Tapped off means you have a tap and you just opening the tap and iron is coming out. In your house, you have a tap, water comes out. Over here, iron is coming out. Any questions?
No, sir, but what does slag mean?
Slag. Now, there's no slag here. Where's slag? I'll tell you. Oh, slag. Okay, I'll tell you what slag means. Just a second. That's step 4. Step 4 is slag. I told you there will be a step 4, and we'll see over here. The impurities are removed. Keep writing.
Sir, can you move to that box where you changed it?
Which one? This one? Third
Six.
point. I changed the third point. The impurities in iron ore, let's say, okay, iron ore, which is sand slash SiO2, silicon dioxide, slash also called SiO2, is removed by reacting with limestone. The molten mixture of impurities mainly calcium silicate is called slag. Now the definition of slag is right here. Slag. Safa, read the fourth point out loud.
Impurities in iron ore, sand, silicon dioxide, SiO2 is removed by reacting with limestone. Slag, the molten mixture of impurities, mainly calcium silicate, formed in blast furnace.
So the answer in the exam you write for slag is the molten mixture of impurities formed in blast furnace. Now Diana, read the fourth point one more time. Diana,
The first one,
the fourth one. Yes, from the beginning. Fourth point.
impurities in iron are sand, silicon dioxide, is removed by reacting with limestone, calcium carbonate.
Limestone is called calcium carbonate, also called CaCO3 or calcium carbonate. Sand is the same as silicon dioxide, which is also called SiO2 or silicon dioxide. Now, this is the two equations in step 4. Part 1. Part 1. I'm teaching you everything. And if you can know this, then you can answer every question in the exam. We first learn, then we solve questions. Now, Lula, read the formulas here. Equations, part 1 and part 2.
Part 1, calcium carbonate equals to calcium oxide plus carbon dioxide. The lime produced then reacts with the silica to form calcium silicate slag. Part 2, calcium oxide plus silicon oxide equals to calcium silicates.
Calcium silicate. Okay. let's remove this first and let's write something else here. But for part 1, we have limestone thermally decomposes to calcium oxide and CO2. That's part 1. The equation for this is CaCO3, or let's say limestone, gives us CaCO3 gives us CaO plus CO2, gas, liquid, solid. Then what happens is that CaO reacts with calcium oxide, reacts with silicon dioxide to form calcium silicate. The equation for this is CaO, let's say CaO gives us, or no, plus SiO2 gives us Ca calcium silicate. Now, okay, now I want you to write this. Now it's quite long, you're writing quite long, but these are the 4 steps. There's nothing else they'll ask in the exam. That finishes the extraction of iron. Now, how much have all of you written? Tell me.
I have reached the last part 2 equation.
Sir, I'm writing part 2.
It's like hard.
Okay, that's, well, you're catching up very good. Diana, what about you?
I'm starting with part 2.
Write it like this. And remove the state symbols. They won't ask you that.
Answer.
Done. Now, okay, I want you to change one thing, not much. Over there, reacts with silicon dioxide to form calcium silicate. You can write this as plus. You don't have to write this, but just understand that these mean the same thing. Okay. This is your word equation. Calcium oxide plus silicon dioxide gives us calcium silicate. Or calcium dioxide reacts with silicon dioxide. Calcium oxide reacts with silicon dioxide to form calcium silicate. Just add one thing above these things. Write plus here, and in to form make an arrow like this. You understand that the word equation is calcium oxide plus silicon dioxide gives us calcium silicate. The same thing here. Just add one more thing. After calcium, after limestone, just add calcium carbonate. That's it. Nothing else.
Done, sir.
Done. Everyone done? How much is remaining?
I'm done.
Done. Okay. Diana and Luna, tell me.
We're done, sir.
Done. Extraction of iron. Let's do some questions on this. Now, okay, I want you to read, let's say, you have the whole step on the screen. I'm going to do a quiz. Whoever tells me the correct answer gets a point. Is that clear? Zahra, Safa, Diana, and Lula. The one to answer first gets 2 points. That's how it works. So first is 2 points. Correct is 1 point. Now, first question. Give me the equation for the second step of iron extraction.
Carbon dioxide plus carbon gives us carbon dioxide.
Perfect. So that's 1 point for Zara. Okay. Well, that should be, well, okay. First answer. So 2. The rest of you, I want one more person to answer this equation. Answer the question. The question is second step of the extraction of iron. Well, I'll give you 1 point, and I'll ask another question. All of you ready?
Yes.
No double points because you can't answer that fast. So second question is, tell me, how is molten iron removed from the blast furnace?
By burning.
No. How is it removed or taken out of the blast furnace? Answers, think. It's in your
By
notes,
slag?
it's on the screen. Not by slag, no. Iron, how is iron, molten iron, removed or taken out of the blast furnace? Molten iron.
By reacting with
By
lime.
reducing the carbon monoxide.
Yes, reducing with carbon monoxide, and then molten iron is tapped off from the bottom of the furnace. So what is the answer? So third step. Iron ore is reduced by carbon monoxide, then molten iron is tapped off from the bottom of this furnace. So you gave the third answer, third step, so that's correct. You have 200 right now. I want the rest of you to answer as well. Now tell me, what is the impurity in iron ore?
Sand, silicon,
Sand,
and
silicon.
dioxide.
Okay, so Safa and everyone answer this one, except Zahra, I think. Now we'll make 2 teams from moving on. We have Zahra and Lula. No, Zahra and Diana, and Lula and Safa. Is that clear?
Yes. Yeah.
Now the next question is, can you tell me how is by which equation is carbon monoxide formed? Let's say by which equation is carbon monoxide formed in the blast furnace?
By carbon dioxide and carbon.
Okay, that's 1 point for these 2. So 4 points for this team, 2 points for the other team. The last question is, how do you get calcium oxide? This is for the second team, Safa and Lula. How do you get calcium oxide in the blast furnace? How is calcium oxide formed? And tell me the equation for that. How is calcium oxide formed in the blast furnace? What is the equation for that? Should I pass this question to the next team?
So the equation is 2CaO plus SiO2, which gives you Ca2SiO4.
But the problem is, I'm asking when calcium oxide is formed, not reacting. So the calcium oxide must be forming in that equation. Now next team, Zahra and Diana, by which equation is calcium oxide formed in the blast furnace? Or how is calcium oxide formed in the blast furnace?
By decomposing.
By thermally decomposing. All right. So Safa, read the part 1 of step 4 out loud.
Limestone, calcium carbonate, terminally decompose to give calcium oxide and CO2.
CO2, just carbon dioxide. Same thing. So any questions? I hope that's clear. Let's try an actual partial question. Read the question, Diana.
3 of the raw materials added to a blast furnace used to extract iron from hematite are coke, hematite, and limestones. Name one another raw material added to blast furnace.
What is the other raw material? Now I gave you what is it?
Hot air.
Yes, good job. Correct answer. Now, okay, that's the first one. Again, this will be team wise. So this mark goes to Zahra answered 1, then Luna answered 2. These are 2 teams. So you have 4 points for Zahra, Diana, and Safa and Luna. You have 3 points. Next question. This is from Zahra and Diana, but Diana has to answer. It's 5 marks. Everyone will get some tries. First, Safa, read the question.
A series of reaction occurs in a blast furnace during the extraction of iron from hematite. Describe these reactions. Hematite. Describe these reactions. Include one chemical equation for reduction of hematite, one chemical equation for formation of slag.
Formation of slag. Now look, I've given the answers to you. You have written them in your notebook. All you have to do is copy paste. So first question from I think Zahra and Diana. Diana, you have to answer. Give me one reaction occurring or one step of the extraction of iron. You have, I think, 4 steps, and the step 4 has 2 parts. Tell me any one part of these. So in the extraction of iron, what are the steps? Tell me one step. Should I pass the question?
Sir, you mean to ask those 4 points which you have given us?
Yes, exactly. So it's 5 mark question. You have 4 points and 2 parts for the 4th point. So 1 mark, 2 mark, 3 mark, 4 mark, 5 mark.
So it's limestone, calcium carbonate, thermolytic,
Coke,
calcium
Start
oxide.
from the beginning. Start from the beginning. First step.
Coke, iron,
So you have coke. What happens?
iron.
Iron. But what is the reaction?
2.
Let's say, okay. The first reaction, I'll give you the answer, is going to be from here.
Carbon
Look.
dioxide.
Carbon, or put coke in blast furnace, which burns in air and releases heat, which makes furnace hot. So carbon plus oxygen gives us carbon dioxide. So that's what you have to write. Carbon plus oxygen gives us carbon dioxide. Okay, actually, all of you, I want you to rewrite step 1. Remove the word put from here, cut that out, and instead write this. Coke burns in hot air to make carbon dioxide. Which releases. Now rewrite the first step like this. And put which releases heat as this. Now tell me when you're done rewriting.
Answer.
Done. Now there's one more change I want you to make. In the second step, instead of react, you should write reduced. All of you done?
Yeah.
No, sir.
Rewrite the first step, and carbon dioxide rises furnace and reduced, and is reduced with more coke and carbon put in.
So,
Now you won't believe the answer for this question exactly as I've written here. So all you have to do is copy paste. Let's see how we do that. Zahra done. Safa rewriting done.
No.
Take your time. While the rest of you, just a second, look at this question. Now, in the question, they're asking us, give the reactions taking place in the extraction of iron. Now, all we have to do is, we have to write these steps. So, Diana, what is the first step?
Carbon plus oxygen, carbon dioxide
Gives carbon dioxide. This arrow means give. Okay. Now, we can write that as the equation. But what is the step? Read the step as well. Luna, read the step, first step.
coke burns in hot air to make carbon dioxide, which releases heat.
So we'll write it exactly right here. So we'll say coke burns in hot air. Burns in hot air to make CO2. Carbon dioxide. That's the first step done. For 1 mark, you got the 1 mark. And after this, you can write the step or you can write the equation. Both are fine. Okay. You could have either also written, or you could have written C plus O2 gives us CO2. That's the equation here. C plus O2 gas gives us CO2. Now, Safa, have you finished writing?
Yes, sir.
Zara?
Yes, sir.
Now, in the second, tell me the second step of this process. Read the second step.
Carbon dioxide rises in furnace and is reduced with more carbon.
Put in. So the answer will be for the second mark. Let's write. This is the first mark. 1 mark done. Second point is we'll write carbon dioxide is reduced. Is reduced with more coke put in. With more coke. That's what's written here. Carbon dioxide is reduced with more coke put in. Next. Now, third step. Any questions, anyone? Are you able to understand my handwriting? Or should I write properly? Now, Lula, any doubts?
No, sir.
Safa? Zara?
No, sir.
No, sir.
Diana? Okay, then let's continue. Now, second step is done. Carbon monoxide reacts with that. Perfect. You can also have written, or you could have written the equation. Both are fine. So just write this, you'll get 1 mark. Or write this, you'll get 1 mark. But we're writing the exact words. Now, the third step. What is the third step? Read the third step, Diana.
Iron ore is reduced by carbon monoxide, then molten iron is tapped off from bottom of furnace.
Fairness. But the issue is that this part is not a reaction. Is it a reaction? No, it's just removing it. So that's not a reaction. The question is only asking about reactions. Describe these reactions, a series of reactions. So they're not asking about how you remove it. So we just have to write this part. Iron ore is reduced by carbon monoxide. The third answer is iron ore is reduced by carbon dioxide, carbon monoxide. Any questions? Now over here, we also have to write carbon dioxide is reduced with more carbon to make carbon monoxide. That's the third step done. Now, okay, again, in the second step, I want you to add one more thing. In the second step, remove, put in, cut that word out, and just try to make carbon monoxide. Any questions, any problems?
Yes.
Now, why am I giving you these steps? Because if you can memorize them, you're getting easy marks in the exam. Just write it, memorize it, and write the same thing in the exam. Also understand it. You have to understand as well. But if you have not understood it, ask me. After you understand, then memorize it. Now, so we remove put in. We just write carbon dioxide is reduced with more coke / carbon to make carbon monoxide. Also, actually cut this part as well, rises and furnace, and cut that part. To make it easy for you, just cut it. Finished?
Yes.
Yes, sir.
Now, next thing is, now when you write the third step, you should write the equation. For all these steps, you also have to write the equation with it. Otherwise, you'll not get the marks. Write the step, then write the equation. Step, equation, then the third step, we have written the third step. Got in the mark, good. Then step 4. What is the step 4? We don't have to write this part. We have to write directly go to part 1. So step 4 is part 1. Read step 4 part 1. Safa.
Limestone terminally decomposed to calcium oxide and CO2.
Carbon dioxide or CO2. So we'll write that here. Fourth step is, step 4 is limestone. Tell me, Diana, what do I write? Limestone. What do I write here? Step 4, part 1. Limestone decomposes to give calcium oxide and carbon dioxide. So limestone decomposes, but we don't write we write thermally decomposes. To give calcium oxide and carbon dioxide, CO2. Done. That's the fourth mark. Again, we'll give the equation for this. So CaCO3 will give us CaO plus CO2. Now, fifth step, last step. Luna, read. Step 4. Step 4, part 2.
Calcium oxide reacts with silicon dioxide to form calcium silicate.
Calcium silicate. So we'll just write it here. Calcium dioxide reacts with the whole same point here, right? And we'll give the equation. What is the equation? SCaO plus SiO2 gives us Ca2 SiO4. Right? We'll write that here. Now again, I want you to make some changes here. Remove the 2 from the beginning and remove this 4 and this 2 and add 3. Tell me when you're done. Now that equation is also correct. You have in the marks scheme, you have option. I think this is easier for you. All you have to do is calcium oxide from here plus SiO2 gives us CaSiO3. Tell me when you're done.
Done, sir.
Done, sir.
Okay, now that's the last step. We'll write the equation. CaO plus SiO2 gives us CaSiO3. And we get the 5 marks here. Any questions? Any questions? Think and take your time, ask me. If you have a problem with any steps, if you don't understand what's happening, you can ask me. Should I move to the next question?
Yes.
Now, Diana, read the question.
Iron extracted from hematite using a blast furnace is impure. Furnace. Identify the main impurity in this iron and explain how it is removed in the steel making process.
Okay. Now you have to write this one more time. Let's go here. I'm giving you a different question. And below this whole step, this whole process, write question. The question is, after iron is removed, there is, let's say, what is another main, let's say, what is main impurity when making steel? Answer is impurity is carbon. And the removal is step 1, step 2. The removal is basically blow hot air, let's say blow or pass oxygen through molten iron, carbon dioxide escapes. Carbon reacts with oxygen and carbon dioxide escapes. Let's say to give carbon dioxide which escapes. Now finish writing, tell me when you're done.
Done, sir.
Done. Diana?
Done, sir.
Done.
So I'm still writing.
If still right, no worries. No. We'll do one more question, iron. Now there's a lot more in this chapter, but I can only do so much in one class. I hope you understand all these steps now. Now, just a second. Let's see one more question. Okay. Another question, we won't write a lot here. We just talk about it and then we're done. Now, Safa, are you done writing?
No, sir, just the last point.
Take your time, take your time. Now the others, I want you to answer the question in the chat. Question 3A. If you can read it, answer in the chat. 3A. Now don't say the answer, write it in the chat.
It's bigger. I can't.
Yes, I can. Now is it can you see now?
Yes, but it's not clear.
I'm done.
Yeah, I understand that. That has to be the case. Now Safa done?
Yes, sir.
Okay. Zahra? Now
Yes,
read
sir.
the question. Read the question, Zahra.
Iron is extracted from its ore using coke in a blast furnace.
Diana, first part.
Name the ore of iron, which is mainly iron 3 oxide.
Iron 3 oxide. So what is the name of that ore which we have been talking about? Answer. Now from Zahra and Lula, I want the answer in the chat. And Safa and Diana, I want the answer. Say it to me. What is the ore of iron called? Say I don't know, or ask me if you have doubt. No silence is allowed.
Sir, can I say
Say
hematite?
hematite. Any questions, anyone? You have written this in your notebook, right? Hematite. That is what it is called. Ore of iron. Now then, read the question, Luna.
So can you explain me again?
Yes, Safa?
Can you explain me?
Yes, I can. Now look, you have something which they're asking what is the ore of iron oxide, iron called. So let's go above and let's see in our notes what I wrote. What is the ore written here, Safa? Read the answer.
Hematite.
Hematite. So the answer is hematite. And the raw materials are also given. Coke, iron ore, limestone, and hot air. Those are the raw materials. But they're not asking the raw materials, they're asking us the ore. And ore is called hematite. I hope that's clear. Now, Lula, read the question quick.
B. Describe the reactions occurring in the blast furnace. In your answer, include 3 points. 2. The reactions for using coke in the blast furnace, a chemical equation for the reduction of iron trioxide, an explanation for using limestone in the blast furnace.
Limestone in the blast furnace. Why do we use all of these things? That's what they're asking. Let's read the answer just 1 second. Now, if all of you will have your own books for chemistry, it will be easier for you to read. It's kind of blurry if I take it from the book. Now, read. Safa, read the answer.
Coke is reducing agent.
Or
So should I
Coke. Continue.
for reduce Fe2O2?
O3. I'll make it more clear. Just a second. Zahra, read meanwhile.
Coke is a reducing agent, produces reducing agent, produces carbon monoxide. Or should I read the or thing too?
Yes. I'll underline this here. So you have to underline, you have to write for the underline. Now, the first thing is just a second. Yes, okay. So reasons for using Coke. So write this in your notebook. Why do we use Coke in extraction of iron? The answer is right here. Step 1, Coke reacts with oxygen to produce heat. So how do you make the furnace hot? You have to make the furnace hot. And we realize that the Coke reacts with oxygen to produce heat. Next thing is Coke reduces Fe2O2, Fe2O3, iron ore, producing iron. Write these 2 points, tell me when you're done. Answer.
Sir, is agent
Yes.
and heat same?
Reducing agent? Reducing
Yeah.
agent is something else. Safa, reducing agent is something that gets oxidized. Now, do you know what reduced or oxidized mean?
Yes.
What is the meaning of reduce? Getting reduced.
Yeah.
So what is the meaning of it? You have 2 words.
Reduce, working it less.
No, not that less, right? This is something else in chemistry. And we have oxidize. Either reduce or oxidize. This is called redox. Now, Lula, do you remember what reduce and oxidize mean? What is the meaning of reduce or reduction?
Reducing agent and oxidizing agent.
Now, what is the meaning of reduction? The rest of
Reduction.
you keep writing.
Reduction.
Yes.
Redox means loss of oxygen and gain of electrons. Oxidation means gain of oxygen, loss of electrons.
So gain of oxygen or loss of electrons. The reduction means loss of oxygen or gain of electrons. Now what's happening is this carbon Coke, which is carbon monoxide, reacts with FeO2O3, and this is what it gives. It takes all the CO oxygen and leaves only iron. So iron loses all this oxygen. Yes, iron has no oxygen now. Safa, does iron lose oxygen from here to here? Yes or no?
No.
It does. I'll tell you why. Look, iron over here has no oxygen here. There's no oxygen. But Fe2O3 has 3 oxygen with it. Yes. So when it goes ahead, it loses oxygen. That process is called reduction. So lost oxygen. Now we'll do this later actually. Reduction. Right now, in the next class, we'll talk about this. Don't think about this right now. But I want you to finish writing this quickly. Tell me when you're done writing.
Sir.
Done.
Done.
Zara, done? Now you have to read, you have to watch the recording, or in the next class, Zara will explain what oxidation and reduction mean. We'll do that again, no worries. Now, if you're done with that, you already know the equations, right? What is the equation for a reduction of iron oxide? Diana, read, tell me. Equation for reduction of iron oxide. Check from your notebook and tell me the answer. Or Lula or Zahara or Safa, tell me the answer. Whoever tells first is better.
Monoxide.
Say that again, yeah, Diana?
Bicarbon monoxide.
Yes, but what is the chemical equation? Carbon monoxide is correct, yes.
Fe2O3 solid plus CO equals to Fe plus CO2.
Plus CO2. That's the answer. Which is you're going to write here, look. Fe2O3 plus CO gives us Fe plus CO2. Now, I think there's something else missing here. We're almost done. Okay. Now in this part, please write these letters here, which I'm telling you. Fine. The numbers are 3CO. So add the 3 over here. 3CO, and you'll get 2Fe, and you'll get 3CO2. Tell me when you're done writing. So in your equation, all you have to do is put the 3 in front of CO for step 3, 2 in front of Fe, and 3 in front of CO2. Done?
Yes, sir.
Zahra and Diana?
No, sir.
Yes, sir. Answer Safa sitting with me right now.
Okay. Safa, can you hear me? Safa, done?
Yes, sir. Yes, sir.
Fine. That's almost done. We're done today. Diana, are you done writing the numbers?
No, sir.
Take your time.
Oh, okay, I'm done.
Done. The last thing is we wrote the equation. We have to write, this is called the balanced equation. So the numbers in front must be correct. Equation. Next thing is why we use limestone in, write the equation. Why do we use limestone in extraction of iron? And all you have to write is these parts. So limestone decomposes to calcium oxide, which reacts to remove acidic impurities. This part? Well, it's the same thing as part 4, but this is shorter. So rewrite it and find it as the answer for this question. Answer is 1 and 2. For the first step is 1. Second step is limestone is involved in the production of slag. Limestone, calcium oxide, is involved in the production of slag. Let's say calcium oxide. This. Tell me when you're done writing. Finished? How much?
Answer.
Done.
Me too.
Safa,
No, sir.
Zara,
Last line.
okay. Now, usually our classes are not this long, but since you have to finish for your test, that's why I'm taking, I think, 20 minutes longer. Finish, Zara, Safa.
Yes, sir. Sir, after this, can you zoom out at the main 4 points so I can just take a screenshot and make my corrections later on? Because after this, I
Fine.
will make a separate note of it.
Fine. Finally, so that's all for now. The next class we're going to look at. There's only two things remaining in the chapter now: extraction of aluminium by electrolysis and rust prevention, which is galvanizing. Look at that in the next class. Now, quickly, Diana, can you recap what did we learn in this class? Quick. I can't hear you.
We learned about the impurities in iron
And
about how
Safa,
copper reacts
yes.
with oxygen.
Safa, what else did we do? Quick recap.
We studied about reactive and less reactive and unreactive metals.
Okay. And
And
Zahra.
and we studied about the 4 points for the core or for the ore and
For
raw
extraction of
materials.
metal, raw
Yeah.
materials. Lula, anything else we did? I'm recapping so you guys don't forget after you leave this class. Lula, what else did we do? Anything else? Zara, take the screenshot. If anyone else wants to take a
Reactive
screenshot,
metals with carbon.
carbon. All right. Now, if anyone wants to take a screenshot, you can. So these notes are, if you can memorize this, then in the exam they'll ask you exactly the same word, because I've given the exam, I know what they ask. There were some changes I had to make, but other than that, everything is exactly based on the mark scheme. So don't study from the mark scheme, study with me, and I'll tell you what the mark scheme wants, so you actually understand. If you copy from the mark scheme, you won't understand what is happening at all. So I hope you understand something in this class, you learned something.
So can
And
you
that's all
zoom
for
in
now.
a bit more?
Zoom in. Okay, where? This?
Yeah, that's enough.
Okay. Now, in the next class, we're going to do extraction of aluminium and rust prevention through galvanization and sacrificial protection. That's all for now. That's it. Just stay for a second.